Hi guys, I am Ganesh Padesur. As you all know, I am studying in STM Engineering College, Davulgiri, Dharwad. I am studying in Electrical Engineering branch about voltage and resistance. We concluded intuitively that in between voltage and current, there exists a parameter called resistance, which is constant in between two. And we draw a graph between these voltage and the current, we will get a linear curve starting from the origin. In today's video, we are going to discuss inductance. I assume that you have heard about inductor in any circuit, like any induction stove or any home appliances products, electronic products. You will get to know what is inductor. Inductor is a coil of wire. When a current flows through an inductor, there exists a magnetic field around the conductor, and that magnetic field links with the conductor and induces an EMF across the conductor. Rate of change of flux linkage, that is d psi by dt. Psi is equal to flux linkage. Psi is given by L into I, product of L and I, where L is the inductance of the coil, I is the current flowing through the coil. Therefore, by substituting psi value in the voltage equation, we get V equal to L into di by dt. We come to know that if current flowing through the inductor is 1 amperes per second and inductance is 1 millihenry, then voltage equals 1 millivolts. Okay, product of inductance and rate of change of current results in voltage, that is V equal to L into di by dt. V into dt equals L into di by dt while taking dt on the LHS, that is product multiplying with V. So integrating on both sides, we get 1 by L integral V into dt. Let us find an expression for current at a given time, at a time t1. Okay, I of t1 equals 1 over L integral from t0 to t1 v dt plus I of t0. It shows that the current at any time t1 depends voltage at that instance as well as the previous instance. Hence we can conclude that inductance has a memory. Means inductance can store current or flux in terms of current, because flux is produced on account of current. From this equation we also get that the difference in current between time t1 and t0 equals the integral of voltage curve equation. I of t1 equals to 1 over L integral of t0 to t1 voltage with respect to time dt plus I of t0. From this equation we grasped that current at any instant t1 not only depends on the voltage at that instant but also on the previous instance. The difference in current between time t1 and t2 can be obtained by taking the integral of the voltage curve with respect to time from t0 to t1 and dividing that by L, that is inductance. Then we can obtain the difference between the currents at t1 and t0. Guys, thank you for watching.